In this module, we'll discuss the use of the Database Creation Assistant utility, or DBCA, to manage databases. DBCA is an utility that helps us create, manage, and drop databases. This utility simplifies the complexity of the otherwise manual database creation tasks. Let's talk about how this tool can help us. When using DBCA to create databases, you have two methods to do this: typical and advanced. Typical method can be used to create a database with minimal user input. This creates a database from an Oracle-supplied seed database using default values. You cannot customize these values. There is one password for all administrative user accounts. Advanced method is used when you want to customize the database options such as file locations, initialization parameters, database type, different password for each admin account, etc. This option gives you more flexibility into how you want the database created. With Advanced method, you can choose a template to be used to create the database, or you can do a custom database, where you supply all the different inputs. Oracle provides two templates out of the box: OLTP and Data Warehouse. OLTP template comes pre-configured for a transactional workload, whereas with the Data Warehouse template, it is pre-configured for a data warehouse-like workload. Both typical and advanced methods give you the option to create a container database. You can use your Oracle-supplied templates to create new databases, but you can also create a new template from an existing database. One example for when would you like to do this is when you install a package application, such as Oracle Retail or eBusiness Suite. The installation process could take several hours to build the different schemas. You may need to have this database duplicated or cloned to other environments, dev, test, UAT, etc. Instead of following the same database creation options, you can just simply templatize this gold image and then just create a new database using this new template. This will save you valuable time that could be used for other activities. DBCA can help you delete unused or unwanted databases. And you can also use DBCA to create, delete, and plug pluggable databases. Before we start creating databases, just a word about what container versus non-container database is. In a traditional pre-12c non-container database, each database will have its own resources assigned to each database, each with its own memory space and disk space. A container database can have one or more pluggable databases. A pluggable database is a database that can be easily relocated to another container. In a container database, some of the resources, such as memory and disk areas, are shared. Any of the pluggable database can make use of them. You can relocate or unplug a database from one container and move it to another container if, for example, you need to make a more efficient use of overall resources. Let's see how to use DBCA. Let's open a new terminal window. Before we can launch DBCA, because it is not in our path, we cannot find it. So in order to fix this, we need to add the Oracle Home variable to the environment and then add this variable to the path variable. The path variable is used by the session to find all the programs that are available to this session. So let's define Oracle Home. It's all uppercase. Oracle Home equals to U01 app Oracle product 12.0 db home _1. Now we need to add this variable to the path variable, we do this, Oracle home bin, colon, and then again path. So what this is doing is, the $sign Oracle home will be translated into U01 app Oracle product blah blah blah, and will append a bin to this path, and then the current content of the path variable will be added to this string. Once this string is formed, it will be assigned back again to the path. So basically we are redefining the path variable by including this new path, the Oracle home bin path. So now we can launch dbca. I'm pretty sure about it. So, but before we do that, let's create the U02 directory that complies with the optimal flexible architecture, so we can create the database into this new directory. For that, let's sudo to root. Let's create this directory and change ownership to Oracle DBA. So if we now as Oracle go to U02, we can create a file. The database file path will be created during the database creation. So let's proceed with the dbca. Let's go back to the Oracle home directory, which is home Oracle, and let's run dbca. Once database configuration assistant is running, let's select the create a database option. Then click next. Now this is what I was discussing or talking about during the presentation. So you have basically two methods, the typical configuration and the advanced configuration. A typical configuration, you can just create a database as a container database, or if you uncheck this, it will be a standalone non-container or traditional database. I will show you how to create a database using the advanced configuration option. Let's click on advanced configuration and then next. So on the database deployment type, because this is the enterprise edition, we have three different options. We can go with a single instance database or the rack, either in cluster or rack 1 node. Let's select the single instance database. And then in the template, you see there is a general purpose one, there is a data warehouse, and I created a test template moments ago. So let's click on the custom database. You can explore the use of the general purpose or data warehouse, but I want to show you how to create a database using the custom database option. When you have chosen the template, just click next. Now, this step is asking us how we want to name the database and if we want this database to be a container or non-container database. For the global database name is how this database is going to be found in your network. So let's say we want to name this test howto.zone. You see, this Just similar to how we name servers, we can name databases. If we have the global services uh, in our network, and if we ping the database test how2.zone in this case, it will provide me all the necessary information to connect to that database. So the global database name is how this database is going to be recognized in the network. And then the SID, or system identifier, that is how you want to name, or what is going to be the name for this database. So these two are related, but the SID is tied to the database instance. I'm going to use the create this DB as a container database. Remember I was telling you that there are some resources that are shared or can be shared with the database, with the pluggable databases. In 12c release 2, you have now the option to use local undo table spaces for the PDBs. Instead of using the shared one that is on the container database, each PDB can have its own undo table space. Let's select this option. And then how many container pluggable databases we want to create on this container database. Let's create just one for the time being, and then we can add more as needed. Once you have completed the steps, just click Next to continue. Now this option, database storage option, is asking us where do we want to put the database files. Okay, let's select use the following for the database storage. And then on the database file storage type, you will see that there are two types. One is the ASM, or automatic storage management, and the file system. Right now, the only option available for us is the file system, because we didn't install the infrastructure software. The database location, file location, is going to be on their Oracle base Oradata DB unique name. But remember that we just created the U02, so now I'm going to show you how to change this. Instead of pointing to the Oracle base, to point to a new location. So the file, click on the file location variables, and then add a new variable. Let's call it Oradata, and this will be pointing to U02. Okay, now we can change this to Oradata. All right, so this will create a new directory called Oradata U02 / Oradata, and then the name of the database. There is this concept in Oracle that is called the Oracle Managed Files. When we select the Oracle Managed Files, what this will do is, whenever you create a new table space, Oracle will assign a random name to the data files. So this can simplify the management of the table spaces of the disk space by just letting Oracle decide what name it wants to use to name the files. One of the advantages of having Oracle manage the files is that when you drop a table space, because this is a managed file, whenever you drop the table space, it will also drop the data files, all the related data files to that table space. This is especially useful when you have a couple hundred files in your database. Once you have selected the different options, or the option that you want, just click Next. Now it is asking us about the fast recovery area. The fast recovery area is an area in the file system that is managed by Oracle. if we enable the database with archive read logs, those archive read logs will be created in the fast recovery area. And the other thing that it manages is the backups. Whenever you run a backup, that backup will be stored in the fast recovery area. And also can manage what is called the flashback logs. Okay, now let's skip this for now. Let's click next. Remember that I was telling you about the listener. The listener by default runs or listens on port 1521. And if you don't create a specific listener, the database will be listening on this port regardless. It's kind of a default listener with no advanced configuration or anything. It's just a basic listening program. So let's create a new listener. We can add or put any name we want. We can even use the word listener, but it's kind of the default name. And let's change the port to 1523. This will add a new listener on this port with the name listener, and this listener will belong to this Oracle home, to DB home 1, which is the only one we have right now. When you are done adding these details, just click next. Now, in the database options, you see all these pre-selected components will be created and installed on the container database. There is so we have the pluggable databases, and then we have a root container database for all the pluggable databases. This is only an administrative database, basically. So if you see, all these components will be created on the container database. We have the Oracle JVM, the text, Oracle text, multimedia, etc. But some of these components are needed on the pluggable database as well. So what I've seen is sometimes the DBAs or the developers create the database, a pluggable database, but they forget, or just they don't know that in order for them to use the JVM in the pluggable database, they need to click and select this option. It's simply, if you want JVM to be enabled in the PDB, and you don't want to manually add this feature later on, just click on the JVM at this point in time. Once you have finished selecting the different options and the PDBs, just click next. Now the configuration options. Let's just start with the memory. So we have 3 ways to manage the memory in the Oracle database. You have the automatic memory management, you have the automatic shared memory management, and you have the manual shared memory management. So with the automatic memory management, which is found down here, the memory is totally managed by the database. All the different memory areas, everything is managed by the instance. So the different process will identify how much resources each memory requires, and it will adjust the values according to that, to the usage. The second one is the automatic shared memory management. Here you can separate into 2 major areas. One is the SGA, the system global area, where most of the transactions and whatever is happening on the database is going to this area, and the PGA size. The PGA is the program global area. It's basically where everything that is done by the user is stored in this area. And then finally is the manual shared memory management. This is kind of a expert level use. You need to know your application very well. You need to understand how your application interacts with the share pool management, with the buffer cache, with the Java pool, with all the different memory areas, so you can actually fine-tune this and provide the right sizing. If you fall short with a share pool or with a buffer cache, you will start seeing errors, or you will see some performance issues with the database. So my recommendation is to use the automatic share memory management. At least you have some degree of freedom where you can assign more memory to the SGA or more memory to the PGA independently of one another. Now the sizing. When you are creating the database using the advanced method, this is the only time, and you are not using template, this is the only time that you can change the block size. The block size is the smallest unit of storage in the database. When we create a database with a specific block size, this block size cannot be changed. When the data is inserted into the database, the data is stored in blocks of data. The bigger the block size is, the more data we can store in that same block. OLTP databases usually use a smaller block size, no larger than 8Ks, but data warehouse databases may require up to 32Ks in size. Once you have defined the block size that your application requires or is suggested by the application provider, you can specify the maximum number of processes that will be allowed on this database. By default, we have 300 processes, but we can increase this to any other number. The restriction will be basically if we don't have enough resources on the Linux side to support the 500 users. So the next tab is the character set. Now we have to define we have the option to define the character set. The database character set is used to display characters basically on the screen or the application. By default, the one that is selected is the Unicode AL32UTF-8, which is basically used to store multiple languages. It supports most of the languages. If you don't want to use this, you can choose a different character set from the list here. So let's choose the AL32UTF-8, which is the default. The national character set is just an alternate character set that enables you to store Unicode characters. Then you have to define the language. You can use the American or the language that is used in your country, and the default territory, that is the actual country you reside on. Now the next tab is the connection mode. The connection mode, you have two different ways to configure the database. You have the dedicated server mode and the shared server mode. For now, let's keep the dedicated server mode, which basically for each client that connects to the database, there will be one server assigned to that process that will only attend that client. In the shared server mode, you have one server process attending one or more clients. So the architecture under the shared server mode architecture, you can save memory, you can save some resources because these are shared among many clients. But for the time being, just for simplicity, let's use the dedicated server mode. And last but not least, the sample schemas. Let's add the sample schemas to this database. And now let's click on Next. Let's configure the Enterprise Manager to use port 5500, and we are going to skip the register with the Enterprise Manager for the time being. Let's click Next when done. So one of the differences we talk about when using the advanced method is that you have the chance to specify different passwords for the different administrative users. So there are three main users on our container database. It's the sys, which is basically the user that owns the database. This is the super user account. You cannot get rid of the sys or the system accounts. The PDB admin is just an administrative account that is created on the pluggable databases. So you have the option to add different passwords for each account, or you can set the same password for the different accounts. So all these three accounts will have the same password. Now for the database creation options. At this point in time, we have several options of what we want to do with all the information that we have just entered in this assistant. We have the option to create the database right now, or after this wizard is completed. We can save this as a template, so we can use these configurations to be used to create other databases. We have as well the option to generate the scripts, and by generating the scripts, this will allow us just to review the different steps needed to create a database. We can update the scripts, or we can add, for example, if we want to customize the installation and we want to specify different things, and we can do so by modifying these scripts. So let's check the create database, and let's check the generate database creation scripts. Optionally, but I will not do it, you can save this as a database template. Let's click next when done. Now here's a summary of all the activities that will be performed by the DBCA. It will create a new database, it will install all these different components, it will set all these different initialization parameters, the character sets, the different table spaces, data files, control files, grid to log files. If we are okay with this, we can click Finish. I'd recommend you to try the different creation options. You'll see that the custom option takes the longest to complete. This is because it has to build the database from scratch, and that involves building the data dictionary, add the PL/SQL functionality, install the JVM and the other options from ground up. When you use the template, the data dictionary and the rest of the functionality are already included. We are basically cloning a database skeleton into a new database. Unless you have a very good reason to do a custom database, I would not recommend to use this method. The custom DB creation took around 1 hour to complete. I am fast forwarding this till the end. Once the database has been created, just click Close. Now let's review the other options. DBCA, Now let's proceed to delete a database. Click on Delete Database and then Next. Now select the database that you want to delete. In my case, I previously created an ORCL DB database. Enter a sysdba account, that could be the sys account, and then enter the password. Click Next when done. If you had this database previously registered with the Enterprise Manager Cloud Control, now you have the option to delete this database from the Enterprise Manager repository. Let's click Next. This will tell you what it's going to do. It's going to delete some files. In addition, it will get rid of the database. When you are okay with this, click Finish. This will stop the database, and then we'll proceed to delete the database files. Once the database is deleted, just click Close. Now let's work with templates. Let's open the DBCA. Again. Now let's manage templates. For that, let's click on Manage Templates, then click on Next. Let's create a new template. Just enter the name of this template that you want to create. Let's say test 1. The template will be created on the Assistance DBCA templates under the Oracle Home. You can enter a description. And then click Next. Now it will ask you if you want to create a new template based on an existing template, or if you want to create a new template from an existing database. You can specify the data files, you can specify the database, and then what's the username to connect to the database to extract all the data, the metadata. When you have entered the username and password, just click Next. Now, if you are using a standard in your organization, let's say that all the databases are being created under the U02 or some predefined structure, then you can select the Maintain File Locations. Otherwise, it will convert the structure to an OFA compliant. For convenience, I will convert the file locations to OFA structure, the optimal flexible architecture. When you have made your selection, just click Next. Now the summary is telling you what it's going to do. It's going to connect to the test database, and then we'll create a template. One important thing is when the template is being created, it will shut down the database. So basically what this will do is, because we selected to include all the database files to this template, it will connect to the database, it will shut down the database, it will back up those files to then bundle all necessary files into a template. When you are done with this, just click Finish. When the template is complete, you can click Close. Let's go back again to the DBCA. Let's go back to Manage Templates. Now let's delete a database template. Click Next. Just select the template that you don't want anymore. And click Next. It will present you a summary of the task that we'll do. And then click Finish. It will ask you if you are sure that you want to proceed to delete the database template. Select Yes and complete. Now let's manage pluggable databases. Let's click on Manage Pluggable Databases, then Next. Now you can create a new pluggable database, you can delete, you can unplug, or you can configure a pluggable database. Let's create a new pluggable database. For that, let's click Next. Enter the username and password for this database. Click Next. Now you can create a new pluggable database from a PDB seed, or you can create a pluggable database from an unplugged database. Let's create a new pluggable database from a PDB seed. Click Next. Enter the name of the PDB. Let's say test PDB2, the administrator account, PDB admin. Enter the password for this new user. Then click Next. Because we are using OMF, then all the files will be created in the standard location. It will create the default user table space. This is optional, you can skip this if you want. Then click Next. And then Finish. Okay, when the process is complete, just click Close. Let's go back to Manage Pluggable Databases. If you want to delete a pluggable database, just click Next, select the Delete a Pluggable Database, click Next, enter the sys account and its password, then click Next. Select the PDB that you want to delete, click Next. It will delete all these different files. When you're done, click Finish. When this is complete, just click Close. Now let's review the unplug pluggable database. What this will do is just to disconnect the database. It will shut down the pluggable database, and it will save the state of this database in an XML file, in a set of files. So let's unplug the database. It's on the sys, on the test database. Let's connect the sys, enter the password, click Next. The only pluggable database that exists right now is the test PDB. We can create a pluggable database archive that is going to be created under assistant DBC name. You will create a PDB file, or you can generate a pluggable database file set. There is one file for the metadata, and there is another one for the database file backup. These files will be created under Assistance DBCA template. Let's click Next. This will unplug the database. Finish. Okay, now close. And now let's put this pluggable database back into this test database. Let's click on Manage Pluggable Databases. Click Next. Create a pluggable database. And next. Enter the sys account and password. Click Next. And now let's create a pluggable database from an unplugged database. Create using a PDB file set. Let's browse for the file. We just created the test PDB. This is the metadata. This is an XML file. Click OK. And the PDB, the database backup, is already selected. It's a DFP. And you have selected the metadata and the database backup. Click Next. How you want to call this pluggable database? It's going to be test PDB. Enter the PDB administrator. And then click Next. When you're ready, just click Finish. When the database has been plugged again, just click Close. In this module, we review the concept of a container database. We discuss the different methods that we can use when creating a database. We briefly talk about when to use templates when creating databases and how to create a template from an existing database. We deleted the database using DBCA and view how to administer pluggable databases.